Next is discriminant analysis, meaning it is multivariate technique used here to separate two or more groups of observation individuals based on the variables measured on experimental unit, those are samples, and find the contribution of each variable in separating the groups. Now, this model is made up of discriminant function, or for more than two groups, a set of discriminant function that is premised on linear relationship of the predictor variable that provides the best discrimination between the groups. There are two types of discriminant analysis, linear and quadratic. So in addition, the prediction or allocation of newly defined observations to previously specified groups may be examined using a linear or quadratic function for assigning each individual to existing groups. This can be done by determining which group each individual belongs to. So now assumptions of discriminant analysis. Sample out to be free from one another and independent. The variables used as predictors should have a multivariate normal distribution, and the variance covariance matrix for each group should be the same. It is presumable that cases cannot correspond to more than one group since group membership is considered mutually exclusive. That is, no case belongs to more than one group. If group membership is based on values of a continuous variables, then consider using linear regression to take advantage of the richer information offered by the constant variable. The procedure is most effective when group membership is a truly categorical variable. Now, different types. Linear and quadratic discriminant analysis are two variants of a statistical techniques known as discriminant analysis. Linear discriminant analysis, often known as LDA, is supervised approach that attempts to predict the class of dependent variable by using the linear combination of an independent variable. Often, linear discriminant analysis, known as LDA, is a supervised approach that attempts to predict the class of the dependent variable by utilizing the linear combination of the independent variable. It is predicted on the hypothesis that the independent variables have a normal distribution, continuous and numerical, and that each class has the same variance and covariance. Both classification and conditionality reduction may be accomplished with the assistance of this method. Next is quadratic discriminant analysis. It is basically a subtype of linear discriminant analysis that uses quadratic combination of independent variable to predict the class of the dependent variable. The assumptions of the normal distribution is maintained, even if it does not presume that the classes have an equal covariance. The QDA produces a quadratic decision boundary. Now, application. So not only is it possible to solve classification issues using discriminant analysis, it also makes it possible to establish the informativeness of particular classifications, characteristics, and assist in selecting a sensible set of geophysical parameters, or you can say a research methodology. Next, a business use discriminant analysis as a tool to assist in gleaning meaning from data sets. This enables enterprises to drive innovative and competitive remedies, supporting the consumer experience, customization, advertising, making predictions, and many other common strategic purposes. Now, the human resources function is to evaluate potential candidates' job performance by using background information to predict how well candidate would perform once employed. The ability to anticipate market trends that will have an impact on new products or services is required for sales and marketing. This is how the discriminant analysis can be done as an apply in several fields.